In this lesson, we're going to learn about what we call big circle problems, meaning we have multiple angles in one circle to find. So we're given this picture that has, that's called circle O, and there's no diameters that are shown because there's no segments going through point O. EA is a tangent. And then we have this ratio here of the arcs. So the ratio is actually going to be very helpful because the first step I always tell people to do in these big circle problems is find all your missing arcs. Because if you're going to be finding the angle measures, you're going to need to know the measures of the arcs. So if we look, whenever we have a ratio like this, we can rewrite these as 3x, 3x, 4x, and 5x, meaning there's a common factor between all of these arcs. So I'm going to go ahead and just label them. The order does matter here. So AB corresponds to 3. So I'm going to call that arc 3x. BC is also 3x, so those arcs are equal. 4x for DC and 5x for DA. So now I have every single arc labeled in the picture. So all of these arcs have to add up to 360 degrees. So the relationship for these is going to be add them up, set it equal to 360, solve for x, and then be able to plug back in. That's how I'm going to be able to find each of these arc lengths. So combined like terms, we have 9 and 6, so we have 15x equals 360. So divide. So we end up with x equals 24. So I'm going to go ahead and plug back in. So 3 times 24 gives me 72. So this is going to be 3 times 24 as well, gives me 72. 4 times 24 is going to give me 96. And 5 times 24 gives me 120. So now we have all of our different arc measures. So before I get to the angle problems here, I just want to give you a quick reminder of the different formulas. So if you have central angles, the vertex is on the center. Remember, the angle equals the arc, which we don't have any of those because there's nothing touching the center. On angles, inscribed angles, or chord tangent angles, the angle is going to equal 1/2 of the arc. In angles, meaning the vertex is somewhere in the circle other than the center, the angle is equal to 1/2 the sum of the angles, of the arcs, I should say. And the last one, out angles, the vertex is out of the circle, the angle equals 1/2 the difference. So with these formulas, we're going to go ahead and solve this circle. We're going to find all of the missing angles. So really, now that you have all of the arcs, you can pick and choose which angles you want to find. I'm going to start in order, but as soon as I start seeing patterns between the different angles, I'm going to go ahead and just complete them. So I'm going to start with angle 1. I look at angle 1. This is where your index cards can really come in handy, just to cover up the angle and focus on only that one angle and the arc that is intercepting. So angle 1, vertex is on the circle. So it's going to be the on angle. Since I already have my formula over here, I'm just going to go ahead and just plug in just for the sake of space. I'm not going to rewrite these formulas every time. So angle 1 is going to be 1/2 of the arc it cuts into. So it's going to be 1/2 of 96. So if it's 1/2 of 96, that's going to give me 48. Angle 2, if I look at angle 2, is another inscribed angle. Vertex is on the circle. Covering it up with your index cards, only focusing on angle 2, shows you it cuts into the 72-degree arc. So that means this is going to be 1/2 of 72. So we get 36 for that angle. And let me actually label these angles as I find them so that if we see other patterns, we can use them. So I have those two angles. And now that I say that, if you take a look, you have a triangle. I'm looking at this and saying, oh, I have a triangle right here. So isn't it true that these three angles have to add to 180? So not necessarily using a circle formula, but all of our other geometry concepts still apply here. So if I do 180 minus the 48 minus the 36, that's going to give me 96 for angle 8. So I'm going to go ahead and fill that in. I'm just going to say because of the triangle. And then in parentheses, I'll just write what I did so you know the calculation. So 180 minus 48 minus 36 was my calculation for that. And then right away, I'm looking at this and saying, oh, there's vertical angles. So I'm going to go ahead and mark this as 96. So see how I started in order, but then as soon as I start seeing other conclusions, use it. So this is going to be 96, and I'm just going to write VA for vertical angles, just so that you know how I found it. Angle 7, I see right now that these two angles are supplementary. They form a straight line, so you could use that. You could also use the in angles. I do want to just show you that just to remind you of that, because this is like the only other time that you'll be using it in this problem. So since this is the vertex is in the circle but not on the center, we would really be using the arc in front and in back of angle 7, because really you're taking the average of the arcs that form the vertical angles. So angle 7, if I call it an in angle, that means it's going to be 1/2 the sum of the arcs, so the 72 plus the 96. So if I do 1/2 of that, or you could be doing 180 minus 96, remember, because they are supplementary, I get 84. So this is 84. So different ways to think about it. So I kind of filled in all of that. Now if I go back in order here, I look at angle 3. Well, angle 3 is another inscribed angle. Its vertex is on the circle. So angle 3 is half of the arc it cuts into. So if you look at where it cuts into the 120. So this is going to be 1/2 of 120, so 60. That's 60. Look at angle 4. Angle 4 is another inscribed angle. Its vertex is on the circle. It cuts into the 72-degree arc. So this is an on angle again. So this is 1/2 of the 72-degree arc. So that's going to be 36. Angle 5 is one that you need to be careful with. So I'm going to put a star by this. This is that exception to the rule. This is a situation where we have an angle that's formed by a secant. So ED is a secant and a chord. So this angle, you cannot say it is an inscribed angle or an on angle, because even though the vertex of it is on the circle, you have this extra space here that is not included if you just did 1/2 the arc it cuts into. So the only time this kind of situation is going to work is if you have a chord and a tangent, because then you're really cutting into that arc. So for this one, really what you have to do is look at that angle measure 4, which was 36, and say that these two angles are supplementary. They have to add to 180. So I have to use the fact that we have a linear pair instead. So 180 minus 36 is going to give me 144. So for angle 5, we're going to say it's 144. I'm going to write supplementary by it. That's my rule that I use. And I'm going to show that I did 180 minus 36. So again, that's kind of the exception to the rule. So then the other angles that I have left, 9, 10, and 11, if I look at angle 9, you might be thinking the same thing right away. But the difference is it told us that this segment EA is tangent. So this is actually a tangent and a chord angle. So the arc that it's cutting into is this entire arc right here. So if you look again where this is cutting into the circle, so you have this chord and this tangent is cutting into the circle right here. So you have to use this entire arc. So it's basically, for this one, it's an on angle. But if you look at that entire arc, you have to do 120 plus the 96. So it's going to be 1/2 of 216 when you add those two arcs together. So it's 1/2 of 216, which gives you 108. So this one's 108. And then you might be thinking, okay, well, these two angles, 9 and 10, have to be supplementary because they form a straight line. But just to show you again that whole, this is a tangent and a chord angle. It's cutting into this entire arc right here. So if you covered it up with your index card, you'd see this entire arc being used. So it's cutting into that 72 plus 72 arc. So it's cutting into a 144-degree arc. So if I consider this an on angle, it's really cutting into 144 degrees when I add those two arcs up. So when I divide that by 2, you get 72. So it's a 72. And if you look, if this is 72, well, 72 plus 108 is going to give you 180, which makes sense. And it should work out that way. So then the last angle here is angle 11. So I'm going to go ahead and just highlight this whole angle 11. You can see why the index cards can become very helpful because you have all these colors and highlighting and different things happening here. So it's nice to have the index cards to kind of help you see what you need to see. So when I look at this last one here, the blue angle, it's an out angle. The arcs that it's cutting into this arc right here in front, and it's cutting into the arc in back here. So we have this big arc and we have this small arc. So for this one, it's an out angle. So it's going to be 1/2 the difference of the big arc. Now the big arc, remember, is really 144. It's this entire thing minus the 120 in the back, the small arc. So 144 minus the 120. So I'm going to do 144 minus 120, divide that by 2, and you get 12 degrees. So there's your last one. So there you have it. Big circles, step by step. If you were given a ratio for the arcs, make sure you find the arcs first, get everything labeled. Use your highlighters, use your index card, all good strategies. Show as much work. If you had more space, I would want more work shown, but for this, we were kind of limited on our space, so I didn't show as much. So step by step, sometimes more than one way to get an angle too. So just keep that in mind. So go ahead, get some key ideas written down, and do your check your understanding problems.